So today I thought I'd talk about this thing, which is a Scientifica Patchstar patch clamp manipulator. This is basically an XYZ stage with a rotary sensor, which is designed for a particular kind of scientific application, which is called patch clamping. Basically, this is a part of a separate instrument, which is a picoamp level current amplifier. And then on the end of this you'd have a very small micro pipette, which would go right into a cell, and you can pick up bilayers and you can do single cell and bilayer experiments with this instrument. And obviously when you're working with single cells you need to do very accurate, stable manipulation, and that's what this rig is designed to do. So it's basically got actuators which you can manually turn here in X, Y and Z, as it turns out they are basically just bipolar stepper motors, which was somewhat surprising to me. There's no feedback as far as I can tell. I think they're probably optical limits, but I haven't figured them out. But you can see basically each of the this whole thing comes to pieces, and I may post some photographs of the separate kind of pieces later. But basically each stage just has an RJ45 connector on it, and that goes into this little box, which is completely passive and just feeds through in this to this 25-pin printer type kind of D connector. Now that's supposed to head into like a 1U rack mount box, but I don't have that. I didn't get that that 1U box with the rig, and that 1U box is also supposed to connect to this thing, which is then like a manual control, so you can kind of manually adjust. You can see that the X, Y and Z, you can just you can manually do all the manipulations, and you can also connect it to a computer for compute control and a very simple kind of serial interface. I didn't have that box, and obviously that's the box with the stepper motor drivers in, and it's quite expensive. It's more than I was willing to pay. I think it's like £1,000 or something, which seemed a lot to pay for a few stepper drivers, and I don't have any immediate application, so it wasn't worth it. So anyway, I figured I'd try and see if I could drive it myself, and I could. And I'm just using an easy driver and an Arduino as a quick first test, and the thing, it basically works fine. If I just stick something on there so you can see it, hopefully. Not sure if you can see that. Let me move the camera. But hopefully you can kind of see that that turning around. Oh, and that's it at its limit. So let's turn it off quickly. Yeah, I just put it back a bit, and you can see it going out. But this is turning now at 1,000 pulses a second from the Arduino, so 1,000 steps per second. And you can see it's actually turning reasonably rapidly, so maybe it takes about 2 seconds to go around. And the interesting thing about this is that they claim, if you can see on the computer screen, they claim a 20 nanometer electronic resolution. Now I don't buy that this thing has a 20 nanometer resolution. It's not expensive enough to have a 20 nanometer resolution, I guess. I mean, it could do, and I mean I've heard from sales reps that it does, but I'd like to see some information on that. But my guess is what they mean by electro resolution is that's the micro stepping that it does. And in order to get that kind of resolution, you know, it'd have to be using like 256 step micro stepping. An easy driver doesn't do that. So the next step is I'm going to try these these Arduino shields, which use a I forget who the part is by. It's I still don't know who it's by. It's a TMC 260 stepper driver, and that will do 256 microstepping, which would be kind of in line with the specs on the website. It would be interesting to do some experiments with an interferometer to see if you actually get that. But anyway, I was kind of surprised that it just uses bipolar steppers. Anyway, I mean, for that kind of nanometer scale resolution, I'm almost expecting like piezo actuators, because slipstick piezo actuators are rated for around 30 nanometers over a similar range of travel. So I was thinking, oh, it'll be slipstick piezo actuators, but it's not. It seems to be steppers. I was also surprised that it doesn't use five-phase stepper motors, because the Chioseki stuff that I have, which are these kind of stages, use Oriental motor 5-phase steppers, which are, you know, like they're similar to bipolar steppers, but they have 5 windings, so they have more windings, and they're supposed to be more vibrationally stable and higher precision. So most of the stages that I've seen that are kind of rated for high precision use those 5-phase steppers, but then that's in Japan, so I don't know. I think only Oriental Motors do the 5-phase steppers, so maybe that's the thing. Yeah, but the Chioseki one is rated for 1 micron resolution, so I've never seen something that's rated for 20 nanometer. And it may be that the micro stepping helps them out. So yeah, that was just a brief introduction to like the Scientifica thing. I'll probably post a bit more information on the pinout and stuff if I get it working. I may build up a, you know, this is obviously just a quick test. I may build up design a PCB around the 256 microstepping board if I can figure out what I'm going to do with it. I don't have an immediate application, like I say, but it's a cool piece of equipment. So.